Port scanning with Nmap. Port scanning is the process of connecting to TCP and UDP ports to determine what services and applications are running on the target system. There are 65,535 ports, each for both TCP and UDP on each computer. Some ports are known to be associated with particular services. For example, TCP port 21 is known for the FTP service. The first 1024 are the well-known ports, and most defined services run on these ports. Whenever we talk about port scanning, Nmap should come into your mind. The universal port mapping tool Nmap relies on the active stack fingerprinting. Specially crafted packets are sent to the target system, and the response of the operating system to those packets allows Nmap to identify the operating system. In order for Nmap to work, at least one listening port must be open, and the operating system must be known and fingerprinted. We could spend a whole course talking about Nmap. If you have never used it before, I do recommend to check it out before watching the following demo. For this demo, I already set up a Windows Server 2012 machine remotely on Windows Azure to be able to test a real scenario. I will start Nmap with the SYN scan first. And by the way, I'm assuming you are already familiar with Nmap and you know what a SYN scan is. Okay, let me show it to you. So first, you start by typing the nmap command name, followed by the T4 argument, which specifies the speed that nmap will execute, where 1 is the slowest and 5 is the fastest. I have specified the -v option for verbose mode. After that, comes the -pn option, which tells Nmap not to ping to identify active system. The -n option means that no DNS resolution will be made. -ss flag, which means that it's a SYN packet type of scan, followed by the top 100 ports to scan. Then comes the max parallelism option, which limits the number of outstanding probes that are sent out. The -OA switch, followed by the file name, outputs the results to all format: normal, grippable, and XML. And finally, our target IP address. The SYN scan technique is often referred to as half-open scanning because you don't open a full TCP connection. You just send a SYN packet as if you are going to open a real connection and then wait for a response. If the response was a SYN ACK, it indicates that the port is listening. If it's a reset, it indicates it's a non-listener port. And if no response is received after several transmissions, then it means the port is marked as filtered. By checking the results, we can see that this server has 3 opened ports: the 21 for FTP, 80 for HTTP, and 443 for HTTPS. Perfect and accurate results. I love using Nmap. Now let's try another type of scan. The ACK scan, which is identified by the -SA switch. This type of scan is different than the others discussed so far, in that it never determines open or even open filtered ports. It is used to map out firewall rule sets, determining whether they are stateful or not and which ports are filtered. Finally, we will execute the aggressive scan technique. The "-a option enables additional advanced and aggressive options. Presently, this type of scan enables operating system detection, version scanning, script scanning, and trace route. You need some patience for the aggressive scan technique because it's going to take a while to execute. Let's check the scan results. Nmap has identified the services associated to my ports. For example, the port 80 of HTTP is using Microsoft IIS to host the website. And for the operating system gas, it already knew that I'm using a Windows Server 2012 version. Awesome! At the bottom of the list, we can see that Nmap used the traceroute functionality to identify its way to my server on the cloud.